Hi everybody, this is Mr. Nolan, and what I would like to do with you in this video is talk rocks. And I really have two goals for you in this video. The first, most basic goal is to be able to look at a rock and figure out, is this igneous, metamorphic, or sedimentary? Those are our three classes, basic classes of rocks. And so that's kind of the big goal. And then there's kind of a more advanced goal that you should still be able to do, and that is to be able to use a rock's features to infer how or where it was created. You should be able to, like I said, like I've been saying, you should be able to tell the story of how a rock was created just by looking at the rock. So I have some examples to show you here, but these are our goals, big goals. What kind of rock is it? And then what features about that rock tell you how and or where it was created. So let's start with the basic question, the basic goal. How do you tell these different rocks apart? We've got igneous rocks. Igneous rocks are formed from volcanism, so a volcano is doing stuff. Metamorphic rocks form as a result of high heat and pressure, squishing together. The rock is squished, usually deep underground. And then sedimentary rocks, rocks formed from pieces of other rocks, grit, chunks, things. So what are you going to look at in order to tell these apart? By the way, before I start talking about these different types of rocks, a really useful tool is called a dichotomous key, which we've discussed and that I have in another video, show you how to use a dichotomous key. But I'm just kind of giving you sort of qualitative way to tell these apart. So probably the most important question you want to ask is, can I find crystals? If you can see crystals, you know that it is not sedimentary. Only igneous and metamorphic rocks generally have crystals. There's some weird situations in which, yeah, maybe sedimentary rocks have crystals, but igneous and metamorphic are the only ones that we can reliably say are going to have crystals. If you find sediment, which means chunks of rock, sand, or even really fine clay, that means we're talking about sedimentary. Those are sedimentary rocks. They're deposited usually by water. And then if we're looking for evidence of whether it's metamorphic, like I said, this rock has been squished, so we want to try to find evidence that the rock has been squashed, usually like this. Sometimes rock is squished this way, sometimes it's squashed laterally, but a lot of the time it's squished actually vertically from sort of the top down. So crystals, that means it's not sedimentary. If you find chunks of other rocks or sand or clay, that means it is sedimentary. If it's been squished, that means that it's metamorphic. So let's kind of just look at some of these classes of rocks, and I have some examples to go through with you. Let's start with igneous. So you have a volcano that's erupting, or some sort of volcanism, magma, lava, ash flow, something like that. What we want to be able to look for is, one, what are the size of our crystals? What's the size of our crystals? What color are our crystals? Can those tell us something about this igneous rock? And then what's the luster or texture of the crystals? There is one weird example of, well, there's really a couple of weird examples in which an igneous rock does not have any crystals in it. And I'm going to show you one or two of those examples. So let me go big screen here. Okay. So I'm going to show you sort of like the textbook perfect example of an igneous rock. And this is a really beautiful rock, even though it's really common. This is an igneous rock. One of the ways that I know that is it's very easy to see the crystals. Notice how there's dark areas and then there's light areas, right? There's these big chunky crystals in here. And so what that means is that this is probably an igneous rock. This is granite, right? This would be an example of granite. Granite usually has a pinkish color, and there's usually darkish blotches in there. Each different color is a different mineral. And so I can see that there's these dark spots, like this one right here where my middle finger is, and then there's some lighter spots. And we can see the crystals are very clearly defined. If you see them shining a little bit on the screen, that's because each little shine is the face of a crystal. And so we have some really well-defined crystals in this rock. I'm going to show you another igneous rock, which was also formed by a volcano. But notice what's different about this rock. I don't see any crystals in there. They're there, but they're just very, very small. So this is a black rock that has crystals, but they're so small that you really can't see them. And so let's talk a little bit about what this means. If I see that there's big crystals versus really, really tiny crystals, what is this supposed to tell us? So we saw in the Crystal Growth Lab that if you form big crystals, that means that it took the crystals a long time to form. The more time they have to form, the bigger the crystals. If I see teensy tiny little crystals, that means they formed really rapidly. So my question for you is this. Which one of these formed on the surface, and which one formed deep under the earth? The rock that has the very tiny crystals, this black one, this is called basalt, formed on the surface. It cooled off very rapidly, and so it has very tiny crystals. The crystals are so small that you basically need a microscope to see them. They're there, but they're very hard to see. This granite took a long time to form because we see large crystals, right? So it must have taken a long time to form. That means it formed deep, deep underground. So there was some magma that was chilling out probably in a magma chamber or a batholith underground, and it cooled off so slowly that these crystals were able to, the minerals in the crystals were able to migrate together and to actually form separate chunks of minerals. So granite took a long time to form underground, but something like basalt formed very, very quickly. Some other ones I want to show you. This is a pretty good example of a rock which I believe to be identified as gabbro. Gabbro is really similar to granite, only it lacks those pink minerals and it has much darker minerals. And so if you find a rock that's got darker crystals in there, that means it's probably gabbro. But you can still see that there are crystals. I can tell the light from the dark spots apart. Those are crystals, and so this is like granite. It's a close relative. Would be gabbro. It's darker. It's got different minerals. One or two other examples that are a little bit oddballs when it comes to metamorphic rocks. One of them is this one. So you can see how shiny it is. It's almost like glass. It's almost like a blob of glass. This is called obsidian. So a lot of you have been asking about what obsidian looks like. This is it. You can see how it shines on the lights. There's no crystals here. This is magma that cooled so rapidly that not only it cooled quickly, it's blackish, it cooled so fast that no crystals at all were able to form. This one, at least, the minerals formed small crystals. This one, there's no crystals at all. This is like pure silica. And so this is called obsidian. This is basically like a big blob of lava goes flying out of a volcano and splashes on the ground and then throws a bunch of silica all over the place. So this is obsidian. This is another volcanic rock that cooled off so quickly that the gases all came out and formed bubbles. You might recognize this. It's called pumice. This is a kind of a volcanic rock where the lava was full of gas and it effervesced out just like a soda pop, and it forms these bubbles. This will float on water. Pumice is actually so light, it's not dense at all, it will float on water. Whereas obsidian is actually very dense. You can see there's really no gases there. The gases, this was a low gas rock. This was a rock that had a lot of gas in it. So basically the big things to get out of igneous rock: how quickly did it cool? If you see crystals but they're really tiny, that means it cooled really fast. If you see big chunky crystals like granite, that means that it cooled very, very slowly, probably underground. And if you see it's glassy, that's obsidian. If it almost looks like we call this a lava rock, this is pumice, right? If you see bubbles, if it looks really gassy. So let's go to small screen here. Let's think about sedimentary rocks. These are probably the easiest rocks to identify, and they're the easiest rocks to describe. I'll show you some that are very, very easy to identify. Sedimentary rocks means that they're formed from chunks of other rocks that have been deposited, usually by water, but wind can create sedimentary rocks too. So we're going to look for what's the size of the sediment. We're also going to look for any layers or bands. And one thing I'm going to look at here is flakiness. Not like if your friend is flaky and kind of doesn't show up, when he says he's going to show up, but how flaky is it? And I'll show you an example of that. So let me give you some examples of some sedimentary rocks. So here's an example of a sedimentary rock that's formed by shells. It's very clear that this was made from living organisms. These shells formed at the bottom of a sea, maybe a shallow sea, and over time they were buried by other sediments and they became cemented together. This is a great example of a sedimentary rock. This would be limestone. Formed from the shells of creatures that got cemented together. Here's another example of limestone, but the shells have basically been broken up into little pieces, and it fell as a very, very fine sort of rain of this lime mineral. So this is also limestone. We just can't see the little bits. One of the ways that we can tell if it's limestone is if acid fizzes on it, which we did in class. We looked at if it fizzes, that means that there's probably calcium carbonate, which means that it's limestone. So if you see big chunks, or if it otherwise fizzes with acid, that means that it's it's limestone, which is definitely a kind of sedimentary rock that formed at the bottom of some water. Some other really good examples. If there's chunks of cobble or little pieces of rock. Now this will not fizz. This one does not fizz, but it's still got chunks. We call this conglomerate. This is a kind of sedimentary that's going to be formed by swift-moving water like rivers, things like that. Here's another example of conglomerate. You can see those chunks of rock in there. This is a sedimentary rock, which it might kind of be hard to tell at first that it's sedimentary because you really don't see chunks in it. However, you can feel them. So if you just feel this, if you rub it gently with your fingers, you can feel it feels just like sandpaper. And so guess what kind of rock this is? This is sandstone. And sand will carry farther than the chunks of cobble that make conglomerate. So what that means is sandstone is going to form on beaches and maybe a little ways out into the lake or the ocean, but conglomerate is only going to form in places where you have a lot of waves or a lot of swift-moving rivers, things like that. So this forms with fast-moving water. This moves once your water slows down a little bit. If we keep going farther out into the ocean, what we find is that the clay particles move even farther. And clay, when clay is deposited, it forms this. This is called shale. Shale is really clay that has been cemented together, and it forms these flaky little sheets. You can see this nice little sheet. So this is shale. This you can tell apart from basalt. Remember, basalt is igneous. Shale is sedimentary. Notice how it breaks, how it's really flaky. Basalt doesn't do that. Basalt is just going to form kind of a round chunk, but shale is actually flat because it forms in layers, sheets, right? It's deposited as sediment. Sometimes you can identify a sedimentary rock if it has really nice fine bands that are really straight. So here's a great example. This is actually called chert. This is a kind of siliceous sedimentary rock. The particles are clay size, but they're made from silica, as opposed to shale, in which there's other impurities which are sort of mixed in here. That's why it's blackish. So this is a kind of really finely banded sedimentary rock called chert. Here's another example. This looks to me kind of like siltstone. It's not quite, it doesn't have that flaky texture that the shale does, but it does have some banding here, and that banding is probably formed from when the sediments were falling on the bottom of the ocean. Those sediments were formed, maybe with different seasons or whatever was coming out of the rivers at the time. And so there's lots of different kinds of sedimentary rock. You can tell if it's formed from limestone if it fizzes, but otherwise you're going to look for flat pieces, indicates that it's either shale or sandstone, or if it's big chunks, then we have conglomerate. Last but not least, I want to talk about metamorphic rocks. These ones are really cool. These are sort of the oddballs of rocks. You're going to look for crystal shape. That's the really important one. Also size, and then dark or light bands. So let's think a little bit. Get big here again. Let's think a little bit about shale. If I squeeze and press shale and heat it, the particles will fuse together to make this really hard stuff called slate. They look almost the same. However, the slate is much, much harder, and it's heavier, it's denser, it's been squeezed. If I take slate and I keep squeezing it, I will end up with what's called schist. Now, it's a little bit hard to see, but you notice those little kind of pretty, glittery crystals? If you see pretty shiny crystals like that, if they're small, that means you probably have schist. So those crystals have started to recrystallize and form new crystals. If that schist keeps compressing, what's going to happen is you get really beautiful glittery crystals. These are flattened, squashed crystals, and this is high-grade metamorphic, what's called gneiss, G-N-E-I-S-S. And you can even see there's a little bit of banding. You can see there's some white and dark bands there. So those are different grades of metamorphic rocks. And then lastly, I can take some sedimentary rocks and I can expose them to high heat and pressure, and I end up with a metamorphic sedimentary rock. Here's a great example. This is marble. I know it's marble because if I put a little drop of acid on it, it will fizz. However, it's much denser than the limestone that we looked at here because it's been squeezed and it's been pressed really hard. Lastly, this is some quartzite. This is if I have sandstone that's been compressed really hard. Notice I don't see or feel any sand in here. It's actually like one big chunk of crystals. And so quartzite is basically sandstone that's been compressed under high heat and pressure, again, to get a metamorphic rock. So I hope that this video was helpful in being able to tell what kind of rocks are we looking at and make inferences about how that rock was created.